Okay, in this video we're going to look at trigonometric equations. So a trigonometric equation is an equation that involves trigonometric functions. To introduce some of the terminologies and ideas, let's look at this straightforward trigonometric equation. Suppose I want to solve sine x equals to 1/2. This can be achieved graphically by plotting the graph of sine x and then plotting the graph of y equal to half, and then looking at all the intersection points of these two. So we're saying the solution of this equation are the intersection points of y equals to sine x and y equals to 1/2. So what does y equals to sine x looks like? Let's just do a quick sketch here. If this is y equals to 1 and this is y equals to -1, so this is y equals to 1 here, y equals -1, then sine x is going to look something like this. Okay, repeats itself over and over. So that would be a sketch of y equal to sine x. Then of course y equals to 1/2 is going to be midway between 0 and 1. So 1/2 is going to be something like that. So that's y equals to 1/2. So our solutions here are going to be all these points where y equals to 1/2 intersects y equal to sine x. Now you can see that there's going to be lots of them. So actually I'm just going to go to another screen and actually plot this on a graphics calculator and show you that there's going to be really lots of them. Alright, so here we are. Here I have got the graph of y equals to 1/2. Now I'm going to plot the graph of y equal to sine x. So sine x there we go. Let's just put this on full screen. Now we can see that we're going to have lots of these points where the two are intersecting. We can go this way as far as we want, and we can go the other way as far as we want. There is going to be lots of these points. Okay, so when I'm going to go back to the other screen, so the thing worth noting here about these points is that for instance these two between here and here, they are going to be separated by 360 degrees. Same thing, this one is going to be 360, this one and this one 360, etc. So we'll see how this relates to what we defined as coterminal angles before. Now, so having seen this, so when solving a trigonometric equation, there is what is called a general solution. Okay, so a general solution is going to be the set of all angles that satisfy the equation. So I'm going to abbreviate this GS. Now, as we've noticed in the example, this set is typically going to consist of an infinite number of solutions. So this is typically going to be an infinite set. Okay, then there is what is called a particular solution. Okay, so a particular solution is going to be a selection of angles satisfying the equation in a given range. Okay, so in a given range. So in the general solution, the range of angles is not given, so that means the range is infinite. In a particular solution, the range or the interval is going to be specified. For instance, in this example here, they could say find all solutions between 0 and 360, or between minus 180 and 360. All right, so in terms of a Venn diagram, if this is your general solution, your particular solution is typically going to be a subset of the general solution. So as you will see, we will first find the general solution, and then from there we will find the particular solution. So let's look at some examples. All right, in this example, we are going to solve trigonometric equations. We're going to find first the general solution, and then we're going to find a particular solution in this range. Solutions, we're going to express them both in degrees and radians. Our first equation is this one that we talked about earlier, and then there is a few others. So let's start with that first one. Sine x is equal to a half. So sine x is equal to 1/2. There's going to be a few steps we're going to go through here. The first step, we are going to ask the question. So the the example is posing a question: find x, so that sine x is 1/2. Now the number on the right hand side is positive. That means we need to find an angle x whereby the sine is going to be positive. So we're going to ask the question, in which quadrant is sine positive? Then we're going to do a little sketch here. And then we're going to recall that actually sine is positive in the first quadrant. So we expect an angle in the first quadrant. Sine is also positive in the second quadrant. The relationship between these two angles is that they are going to have equal reference angles. So they're going to have equal refs. Okay, so that is the first question that we need to ask for this one. So for instance, in part B, we're going to ask the question, in which quadrant is cosine negative here, in which quadrant is tangent positive, in which quadrant is sine negative, etc. Then after that, we need to make sine the subject of the formula here. Sorry, x, not sine. So by making x the subject of the formula, we have got to transpose sine to the right hand side. So that means it's going to be inverse sine 1/2. Then we expect two angles here, because one is in the first quadrant, the other one is in the second quadrant. Then we punch this in the calculator, and then just note that the calculator computation is only going to give us one of these two angles here. So the computation is only going to give us one of these two angles that we expect here, and then the other one we have got to work out using the fact that these two angles have got equal ref. Alright, so inverse sine 1/2 is 30 degrees, so clearly that is the one in the first quadrant. Okay, then it means this is also 30, and if that is 30, it means the one in the second quadrant is 150, being 180, take away 30. So those are our two angles that solve the equation sine x is 1/2. Now, however, for the general solution, we have got to find all the angles. So if you like, all that we have done in this diagram is we've located these two angles here. So we have got to find all these others. Now we have already noted that these are related by the interval of 360, or in terms of this diagram here, we have got to find all the coterminal angles of 30 and all the coterminal angles of 150. So we remember that coterminal angles of 30 we find by adding or subtracting multiples of 360. So we can do that here by simply saying plus 360k, where k is an integer. If k is 0, this is just 30. If k is 1, is 30 plus 360. If k is 2, is 30 plus 360 times 2. Same thing here. We're going to have 36 plus 360k. And then, of course, we specify that k is an integer. This is now the general solution, and it's complete. All right, so let's go to part 2. In part 2, we want a solution in this interval. Just before we go to part 2, got to write these in radians. Okay, so let's just write those in radians. So in radians, x is going to be 30 is pi over 6. 360 is 2 pi. 150 is 5 pi over 6. 2 pi k. So that's going to be the answer in radians. Now let's go to the second part. In part 2, we want all values of theta in this interval. In degrees, this is the same as the interval between -180 and positive 180. So one way of doing this is using a number line. So if this is 0, 90, 180, -90, -180. So we want all angles in this interval. This side is curly brackets and this side is square brackets, because we've got an equal sign this side. And so we want all angles in this interval here. So what we're going to do is let's start by working this out in degrees. So take 30 for instance. When k is 0, that gives us 30, and then question is 30 in this interval? And the answer is yes, 30 is there. And then the next thing I want to do is we're going to take k is 1. That gives us 30 plus 360, which is 390 degrees. Question is 390 in this interval? And the answer is no. This is 180, so 390 is this side. So this is not part of that one. So that means we don't have to wind this to the right anymore. So we wind it down to the left. So we're going to do 360 or 30 minus 360. So that is going to be -330. Okay, I'm sure you're going to notice that these are just the coterminal angles of 30 that we did earlier. It's -330 in this interval, and the answer is no, because if that's -8, -330 is that side. So that means that is not part of that interval. So the only angle that is in this interval is 30 from this group of angles here. Then we do the same thing for 150. So for 150, when k is 0, we've got 150, of which 150 is somewhere here. So we write 150 down. Then when k is 1, 150 plus 360 is going to be outside this range. Then when k is -1, 150 minus 360 is going to be 150 minus 360 is -210. Well, -210 is going to be somewhere this side. So again, 150 is the only value. So for part 2, our answer is just going to be 30 and 150. So in radians, pi over 6, 5 pi over 6. So that rounds up the first question. Okay, so then in B, we have cosine theta is equal to -1/2. I'm going to start doing this one a bit quicker because we've already established the routine. So the first question is about the quadrant. In which quadrant is cosine negative? So cosine theta is negative in quadrant. It's not the first quadrant, definitely. But cosine theta is negative in the second quadrant. So we expect an angle here. Cosine theta is negative also in the third quadrant. Remember, the third quadrant, both cosine and sine are negative. So this angle must be equal to that one there. So the answer here is quadrant 2 and quadrant 3. Then we're going to make theta the subject by moving cosine to the other side. So we're going to have cosine of -1/2, which we punch in the calculator. So we're going to have inverse cosine -1/2 equal. That gives us 120. 120 is in the second quadrant, so we have 120 here. If that is 120, then this reference is 180 minus 120. So that means that reference there is actually 60 degrees. Got 60 here, so we also must have 60 there. That makes this one 180 plus 60 is going to be 240. So that means our two angles here are going to be, just space this out. So our two angles here are going to be, so theta is inverse cosine -1/2. So the first one is going to be 120 plus 360k, make it general. The second one is going to be 240 plus 360k, where k is an integer, right? So that is the general solution in degrees. In radians, 120 is 2 pi on 3. 360 is 2 pi. 240 is twice this one, so it's going to be 4 pi on 3, 2 pi k. Okay, so then in part 2, we need angles between -180 and 180. So if we start with this one, 120 is between -180 and so that is okay. Then if we do 120 plus 360, we find 480, which is outside. So next we try 120 minus 360. We'll find -240, which again is outside that range, because if this is 180, -240 is somewhere there. So that's going to be all the angles we can get from this one. Then we go to this one. So if k is 0, we've got 240, but 240 is here. So that means this angle cannot be part of the solution here. But since it's this side, we need to wind it down. So we need to start subtracting multiples of 360. So we're going to say 240 minus 360. That gives us negative 120. Negative 120 is going to be somewhere here. So negative 120 is fine. And then if we subtract another 360 from 120, then that gives negative 480, which is now outside. So that means our two angles that fall in that interval are these ones, 120 and negative 120 in radians. So this is just going to be 2 pi over 3 and negative 2 pi over 3. Okay, so that completes that second example. Just notice that here, if we write them like this, you have got one angle and then you've got the negative of the other, which is agreeing with what we said in terms of cosine being an even function. So cosine of theta is the same as cosine of negative theta. So of course cosine 120 is going to be the same as cosine of negative 120. All right, then the next example, C, is sine theta minus cos sine x minus cos x equal to 0. Okay, so sine x minus cos x is equal to 0. What we'll do here is we're going to take cosine to the other side. So this thing is going to be sine x is equal to cosine x. Then, assuming that cosine is not 0, we're going to divide by cosine on both sides. So we're going to have sine x over cosine x is equals to 1, provided cosine is not equal to 0. Then this thing is going to give us tangent x is equal to 1, and so that is the equation we're going to solve. So the whole point was to rewrite this in terms of only one trigonometric function. So we're going to ask out the question, in which quadrant is tangent positive? And we will recall tangent is positive in the first quadrant. It's positive also in the third quadrant. Now, if this is equal to that, it means this is going to be a straight line angle. So that means the solutions of tangent x equal to 1 are going to be in a straight line. Right, so we do what we did even before. So we say x is going to be inverse tangent 1 for black, inverse tangent 1. So inverse tangent 1, we find 45. So that means this is going to be 45 degrees. This one here is going to be 45 plus 180, because they're on a straight line. So what we're going to do this time is we're simply going to write 45 degrees plus multiples of 180, because the two angles lie in a straight line. So that's one way we can write this. The other way, which is equally acceptable, is of course we can write 45 degrees multiples of 360, and then the other one in the third quadrant is going to be 225, then multiples of 360. So either we write it like this or we write it like that. Both representations are very much acceptable. All right, so that is in degrees. In radians, 45 is pi over 4, so, and then that's going to be pi k. 180 is pi, or that's going to be pi over 4 plus 2 pi, so pi over 4 plus 2 pi k. The other one is going to be 5 pi over 4 plus 2 pi k. And then for part 2, we are looking for angles in the interval between minus 180 and 180. So of course 45 is in that interval. Then we do 45 plus 180. That's going to give us an angle outside the interval. 180 plus 45. Okay. Then the other thing we're going to do is 45 minus 180. 180. That is going to 180. 45 minus 180 gives us negative 135, which lies in the specified interval, and you'll find that those are the only two that are going to lie in that interval, negative 3 pi over 4. So that is part C. We're just going to do part D. So in part D, we have tangent theta plus 30 degrees is equal to square root 3. Yeah, so again we're going to ask ourselves the question, because this is positive, in which quadrant is tangent positive? And of course the answer, we've already addressed that one. First quadrant and third quadrant. Then we can make theta plus 30 degrees the subject of the formula by punching inverse tangent of square root 3. So inverse tangent square root 3, and the answer is 60. So we're going to have 60 degrees. Then since the angles lie in a straight line, we're simply going to say 60 plus 180k, where k is an integer In radians, this is pi over 3, and this is pi k. And then for part 2, we are not done. So what we have here is theta plus 30. We need theta, so that means we need to make theta the subject of the formula, taking 30 to the other side. That means we're going to subtract 30 from there. It's going to be 30 plus 180k. So yeah, that is going to be our solution, which is pi over 6 plus pi k. Then for part 2, which of these values are going to be between minus 180 and 180? 30 will be, the other one will be 30 minus 180, which is going to be minus 150. Then we write these in radians. It's going to be minus 5 pi over 6. Okay, we're going to stop here. The rest of the examples we are going to do in the next video.